Good day all of you. Today's gate question is a cascade of common source amplifiers and a unity gain feedback configuration oscillates when the options are the closed loop gain is less than 1 and the phase shift is less than 180 degrees. The closed loop gain is greater than 1 and the phase shift is less than 180 degrees. The closed loop gain is less than 1 and the phase shift is greater than 180 degrees. The closed loop gain is greater than 1 and the phase shift is greater than 180 degrees. Okay. So if you observe the question, a cascade of common source amplifiers in a unity gain feedback configuration oscillates when. Okay. So what you have? We have cascade of common source amplifiers. We have two common source amplifiers like this. Okay, these two are connected. First output is connected to second input, that is called cascade. And there exists unity feedback like this. Output of the first common source amplifier is connected at the input terminals of the second common source amplifier. There exists unity feedback. Okay, this feedback is unity. Okay, now the system oscillates when, and see, oscillations. To get oscillations from any circuit, first of all, there must be two things. One is the amplifier stage and another one is the feedback stage. This is the amplifier stage. This totally is the amplifier stage and this is the feedback stage. Okay. And now to get the oscillations from this type of circuit, we have a condition or criteria called Bark-Hasen criterion. Bark-Hasen criterion. What is Bark-Hasen criterion? It is the criterion with which we'll get oscillations. What are the points here? The points are, the first criteria is the loop gain. Loop gain mod A beta must be greater than or equal to 1. So that is the first condition. And the second condition, total phase shift around the closed loop is 0 degrees or 360 degrees. Okay, these are the two conditions to get oscillations. Loop gain must be greater than or equal to 1 and the total phase shift around the closed loop is 0 degrees or 360 degrees. I'll explain. What is A here? Amplifier gain. Here, this cascade of common source amplifiers gain, you have to treat it as A. And here we are giving a negative feedback. Okay, now this feedback factor, consider it as beta feedback. So this product, modulus of these two products must be greater than or equal to 1. Another point, total phase shift around the closed loop is 0 degrees or 360 degrees. Okay. In this closed loop, the phase angle must be 0 degrees or 360 degrees. Suppose if the first common source amplifier is giving 180, then the second must produce another 180. The total will be 360. So totally from the amplifier and from the feedback, the phase shift must be 0 degrees or 360 degrees. Okay. So this is Bark-Hasen criteria. In options, if you see, so what is this? The closed loop gain is less than 1. No? Here if you observe, the closed loop gain is nothing but loop gain. Just remember. So the closed loop gain must be greater than or equal to 1. That is the first point. So in the first option it is less than 1. So it is wrong. The closed loop gain is greater than 1 in the second option. But observe the phase shift also. The phase shift is less than 180. No? The phase shift must be 0 degree or 360 degree. Accordingly we must go. Okay. So this is wrong. The closed loop gain is less than 1. Wrong. The closed loop gain is greater than and the phase shift is greater than 180. So this is correct. So the answer is D. Okay, so that is Barkhasan criteria.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.